Hi, welcome to Automotive Concepts. I am Tota Krishna Hema, your automotive subject matter expert. In this session, we are going to discuss about integration testing as per ISO 26262. Let us go ahead into the topic. Likewise, we have discussed in the last week software unit testing. The same way, the methods of software integration testing, also the same methods. It involves 5 different methods of software integration testing. So it is requirement-based testing, interface testing, fault injection testing, resource usage testing, back-to-back comparison test between model and code if applicable. So here if you see A, B, C, D are the SL levels, D is the most critical level and A is the least critical level. And a part of this we have another segregation called QM, so which is not mentioned in this table. So which is if you implement ASPICE level 3 in your project or CMMR level 3 in your project, so it is almost equal to the QM implementation. So let us get into the details of these methods. So requirement based testing or RBT, requirements at the architecture level, because this is the integration testing, so we are taking requirements at the integration level, architecture level are the basis for this RBT or the requirement based testing. RBT is a testing approach in which test cases, conditions and data are derived from requirements. So it involves functional testing and also non-functional testing, non-functional attributes such as performance, reliability and usability. So this testing process, because it is this complete testing process, it should have a time bound, or the time it should execute in a timely manner. The second thing is, so if you look into this software life cycle, so this is the common test strategy or the common test method which we use in any testing. So that's the reason. So it is most effective also. So testing the system exhaustively is impossible. Hence, the testing process needs to be efficient as well. Testing must provide the overall status of the project. Hence, it should be manageable. Interface testing. So this is the second method of integration testing. So which we use in the integration testing. So interface testing, interface of one software component with others is very important, and this test ensures that the interfaces are devoid of any errors. So devoid is so interface is nothing but a communication which is set up in between the two or more software components. So here we will ensure that the particular component or the system is passing a correct data to the to another software component. So we will ensure components pass data and control correctly to one another. So it is to verify if all the interactions between these modules are working properly and errors are handled properly. So correct implementation of interfaces is very strongly recommended by the ISO 26262 integration test recommendation table. This is because every software unit may have been tested individually, but their communication with other components is also very critical. So this interface testing we will do it in unit level as well, because to identify before integration of the software. During the interface testing, the value range of the incoming signals from the interface is defined and divided in classes. These classes have boundary values, so which is used to define the test cases. After the test cases are defined, interface testing can be performed. So here is a checklist or the guidelines we have for the interface testing. So first of all, we have to verify the communication between the systems, and then verify if all supported hardware or software has been tested. Verify if all linked documents to be supported or opened on all platforms. Verify the security requirements or encryption while communication happens between systems. Check if the solution can handle network failures between website and application server. So as I said before, this interface testing is nothing but to ensure the communication and control activities in between or among the systems, among the connectivity of the system. Either it will be the external source like the servers or the website or the host, then your application server. So these all host server and the application server and your website, and this is how it is communicating. We will ensure on. Coming to the fault injection testing. So what is fault injection testing? Is injecting or introducing arbitrary faults in order to test safety mechanism. So corrupting software and hardware components. So fault injection is a software testing technique by introducing faults into the code for improving the coverage, and usually to test the robustness of the entire software, we will test this thing. Arbitrary faults are injected to the software, for instance corrupting the values of CPU registers, introducing code mutations, etc. So when we do code mutation, then we can be able to, we may be able to test the fault injection, and the software must exhibit intended behavior at such instances. Fault injection method is there are two methods in this: compiler time injection and the runtime injection. Compiler time injection, it is a fault injection technique where source code is modified to inject simulated faults into the system. Wherein runtime injection is, it makes use of software trigger to inject a fault into the software system during runtime. The trigger can be of two types. It is like time-based triggers and the interrupt-based triggers. Coming to the fourth category called resource usage testing. So resource usage testing, this test can be is performed to ensure that the component or software component or system being tested does not consume a lot of CPU data. Resource usage testing is usually done on the target platform or a simulator This test is strongly recommended only when the software product is targeting to be SLD compliant. Ensure the fulfillment of requirements influenced by the hardware architecture design with sufficient tolerance, properties such as average and maximum processor performance, minimum or maximum execution times, storage usage, example, RAM for stack and heap, ROM for program and data, and the bandwidth of communication links, example, data buses, have been determined. So why I read this entire content is, this is from the standard book, so I just copy pasted there. So if I miss something here, it would be useful for us, right? So that is the reason I have copy pasted and read it as this. So here if you see, this resource usage test is mostly, it will be conducted on in the target environment, in the target platform or the simulator. We will replicate the target environment, and we will test this resource usage testing. So the next thing is back-to-back, or the fifth method is back-to-back comparison test. So this method requires a model that can simulate the functionality of the software component. Here the model and code are simulated in the same way and the results compared with each other. This test comes into picture when the software is being developed using model-based development method. The model and the code are simulated in the similar way and the result is compared. So if you hear this thing, then you might have get this. If you have the software in your hand, which is developed on model base, then only we can execute this particular testing. So if we don't have a model based development, then we can skip this thing because it is not applicable to the project. So for this test method, a model is required that can simulate the component being tested. The test suits from the source code are applied to the model and vice versa. The results of both the scenarios are compared and the output is recorded. So the next thing is methods for deriving test cases or the software integration test cases. So there are 4 different methods similar to our unit testing. The first method is requirement analysis, then the equivalent partitioning, then the boundary value analysis and the error guessing. So if you see this, the entire table, so plus plus indicates the mandatory things and plus is recommended, or this plus is recommended and plus plus is highly recommended, we can say. So methods for deriving test cases, if we go into the details, the first method is requirement analysis. So every software component will have some behavioral requirements. So these all requirements we will analyze and we will derive the test cases. The requirement analysis is the commonest or the most common method. So it is recommended for all ASIL levels. The second thing is equivalent partitioning or analysis of equivalent classes or equivalent class partitioning. So equivalent classes can be determined determined based on the division of inputs and outputs such that a representative test value can be selected for each class. There is a range of input values for which the behavior of the software component should be similar. This range is called equivalent class. Equivalent class partitioning allows you to divide a set of test conditions into a partition which should be considered the same. The software testing method divides the input domain of a program into classes of data from which test cases should be designed. So in the name itself, if you see there, this is equivalent partitioning. So this is how it is. So this is highly recommended in case of B to D compliance. So the next thing is boundary value analysis. So boundary value, by listening to it, it will have a range, and this method applies to parameters or variables values approaching and crossing the boundaries and out of range values. So we will test to the nearby boundary values. So it's like we will get the range values, right? So this is a minimum one and this is a maximum one. In and around minimum, in and around maximum, we will test it out. So that is how this boundary value analysis will take place. So this is a common test for SLB, CD, and this is based on the boundary values, as we said. So this is completely a black box testing technique, so which complements the error partitioning technique. This is a deriving method, right? So this is one of the how we will derive a integration testing. So this is one of the technique. Guidelines for boundary value analysis. So this is the boundary value analysis. So if you have x and y as the minimum and maximum values of the range, then you have to derive the test cases by considering the minimum and maximum values in and around range. The next thing is error guessing. Error guessing tests can be based on data collected through lessons learned. This is purely on your experience. So why we need an experienced or senior tester in your project is like he or she will get to know the odd or from the historical data or from his own experience. He will tell like, yeah, at this point of time the system may experience a failure. So that is how this is called. This is through a lessons learned process and expert judgment kind of, or it is purely an experience based technique. This technique counts a list of possible errors or error prone situations. So this is the guidelines for error guessing. The test should use the previous experiences of similar application, understanding of the system under test, knowledge of typical implementation errors, remember previous trouble areas, and evaluate historical data and test results. So there is another, so we have completed all the 4 categories of 4 different techniques to derive integration testing, but I would like to cover two more techniques. So the first technique is decision table. This is my one of the favorite thing, because the decision table will enable the coverage, the complete. So it will allow you not to forget any scenario kind of. So it is because it is based on the permutations and combinations of your input values, and this will not allow you to miss any of the combination. So that is the reason. So we have to make a decision table before deriving a test case. So this is highly recommended from my end. It is not recommended from this FUSA or the functional safety. A decision table is also known as cause and effect table. Cause-effect table. This software testing technique is used for functions which respond to a combination of inputs or events. The first task is to identify functionalities where the output depends on the combination of inputs. If there is a large input set of combinations, then we divide into the smaller subsets, which can be helpful in managing the decision table or DT. For every function, you need to create a table and list down all types of combinations of inputs and its respective outputs. This helps in identifying a condition that is overlooked by the tester. As I said, so for the complete coverage of the variable combinations or of the inputs and the possible outputs, we will cover it out. So following are the steps to create a decision table. So we have to list all the inputs, all the possible inputs in a row, and enter all the rules in the column, fill the table, or we will make a library out of the rules and fill the table with the different combination of inputs. In the last row, note down the output against the input combination. The next thing is state transition. So if you have a small data, okay, if you have a limited set of input values, then we will use the state transition technique. So if you have already covered the previous techniques, ignore this thing. But wherein, like, if you have very less values or the input conditions, then you can use this state transition technique. So this is state transition technique. Changes an input condition changes the state of the entire application under the test. So it changes the behavior of the of your system. So that's how the state transition technique is defined as. So if you have, as I said, if you have limited set of input values, this is the best technique to use, and the tester can perform this action by entering various input conditions in a sequence. So in state transition technique, the testing team provide positive as well as negative input test values for evaluating the system behavior. The technique should be used when the testing team wants to test sequence of events which happen in the application under test. The next concept we have to cover is the structural coverage matrix. So we have a lot of we have three different categories. We had three different categories in terms of unit testing, but wherein for the integration testing we have only two coverage metrics. So one is functional coverage, the other thing is call coverage. So this is highly recommended, or this is mandated in case of C and D, and it is recommended in case of AB. Let us get into the concept in detail. Function coverage. Function coverage refers to the percentage of executed software functions. This evidence can be achieved by an appropriate software integration strategy. The functions in the source code that are called and executed at least once. So if you execute all the functions at least once, then the coverage is 100%. If you are able to execute a part of it, then the function coverage percentage will decrease based on it. Functional coverage is important to any verification approach, since it is one of the factors used to determine when testing is done. Specifically 100% functional coverage indicates that all the items in the test plan have been tested. Combine this with 100% code coverage and it indicates that testing is done. That's the test completion criteria. Okay, call coverage refers to the percentage of executed software function calls as a test coverage criteria which checks whether function called 0 times, exactly once, or more than once. Since probability of failure is more in function calls, each function call is executed. Coming to the tools for integration testing. So here is a list of tools. We have VectorCast for C++, VectorCast ADA, Citrus integration testing, LDRA, CETA, and FitnessC, TestC, rational integration testing, Protractor, Validate MSC, Steam, Jasmine, EZ-Script, Spock from Fuzira, and Pioneer.js. So these all are a kind of which fits into automotive environment. So yeah, thank you so much for your time. So if you like this concept, please click on the like button. If you want further more automotive concepts, please subscribe to my channel. Thank you.